Hey, all you Gretas and Shootez cats out there. Welcome to Unit 4, Section 2, Soil Formation and Erosion. Now, the first section was kind of a couple of stations to introduce you guys to some topics on Earth's resources. And now we're going to go into the dirt of it. This is content that's not super hard, but it may be new to you because you probably skipped the Earth, Space, and Science, or Earth Science class. So let's get into it. So how do we make soil? Let's move me up here. There we go. So the first way you can make soil is through physical weathering. So physical weathering is just the mechanical breakdown of rocks and minerals. You have abiotic causes, your non-living things like water, wind, temperature, and then you have biotic causes such as plant roots and burrowing animals, anything that will break down rocks. So this is a physical something that is breaking down the rock. So you can think water collects in a rock crack. That water freezes and expands, forcing the crack to open. That ice will thaw. It'll then contract and the water gets deeper into the cracks again, and then repeat. Expansion and contraction causes further cracks until the rock splits. And so something as seemingly innocuous as water can break rocks in half. And this will increase the surface area, move this down as well, which will lead to there we go, chemical weathering. So this is the change in chemical composition of mineral compounds, whether it's through carbonation, hydrolysis, oxidation, any chemical process that is going to change what's up with the rocks. So here's an example. It releases essential nutrients from rocks. It's a huge important part of the phosphorus cycle. Remember, phosphorus goes from soil and rocks to water and back again. There's no atmospheric stage to the phosphorus cycle. So from there, we have anthropogenic chemical weathering. So we have, I don't know why it is over there, but you have your fossil fuel combustion, you have your sulfur and nitrogen oxides. They're going to, so we burn our fossil fuels. They give off the sulfur and nitrogen oxides, which will come into play in other units too, so remember these things. They're going to react with the water vapor, which is then going to create sulfuric acid. And as that mixes with water, we have acid precipitation or acid rain, which is bad. Next, so here are the effects of acid rain. You have acidification of soils and trees, and plants don't grow well in acidic soil. That's one of the easiest ways. If you remediate the soil and make it less acidic, the plants will grow better. It impairs visibility of where you can, of the things. Human health effects, things like asthma, bronchitis, emphysema, all can be derived from acid rain, and it decays a lot of limestone and marble. So think statues, gravestones, buildings, bridges, literally gets broken down because of the acid rain. So if you go to a cemetery with really old gravestones, you can see they're a little bit smoother than the newer ones, and it's because it's been broken down. So how do you make soil? From below, you have the physical breakdown of rocks and primary material. Those newly exposed materials are going to provide the raw material to make soil. So you have your unweathered rock, your partly weathered rock, your subsoil, and then your topsoil. From above, so from down below, you've got the solid rocks being broken down into smaller pieces. And then from above, you have the deposition of organic material from dead organisms and their waste. So soil is nothing more than tiny pieces of rock, dead stuff, and poop. That's all soil is in a nutshell. All right, so here is an example of young soil. It's hard to see the horizons, which we'll get to in a second. There's not a ton of weathering. You can still see the bedrock right here. It's slightly leached with thin solemn, which is the different layers that have all gone through the same process. Over here, we have older soil. So you can see you've got these nice, gorgeous horizons. There's a lot of weathering that has happened. Much finer soil, much leached. The stuff has gone down through with a thick solemn. You've got these nice, gorgeous, thick layers. So mature soil has much more organic material up top and way more nutrients throughout. But very old soils can, move me back down, be very nutrient poor due to plants and water leaching nutrients. So mature soil, good. Really old soil, probably not the best. Now we're going to go into the soil horizons. So I'm going to give you details on all of these in the next slide. So we have O, A, E, B, C, and R. I did not name them, so I don't know why A, B, and C don't go together. But these are your layers in order. So that would be a really easy test question is, what layer is this? So O, horizon, is the organic layer. So this is decomposed organic material. That lower most decomposed part is called humus, and it's most pronounced in forest. So think of just all that leaf litter and stuff that you see in the forest right on top of that next layer, which is the topsoil. This is your A horizon. A horizon is the topsoil. This is where you would like plant something. So this is the surface soil or topsoil. Organic is mixed with the mineral stuff, the rocks and whatnot. Most biological activity goes here. So the plants live here, the creepy crawlies are playing in this. This is where most of the action is in the topsoil. And this is also where our food grows, so this is our future. E is for alluviated. So in this it's not in everyone. It's in some acidic soils, and this is where minerals and nutrients are leached or alluviated from above. So they'll pull that stuff down. So here's an example. You have your O and then A and then E horizon, and once again, they're pulling those. If it's there, it's fairly obvious. You've got that leached area. B horizon is your subsoil. So we have topsoil, subsoil. This is the mineral material. The zone of accumulation of different minerals and nutrients are down here. So you've got some roots and stuff down here, but once again, most of the biological activity is up above. But this is the subsoil level. Then you have your C horizon, and sometimes they're really nicely separated. This is the least weathered, so the larger pieces. It's similar to parent material, which I'm getting to in a second. Not too much excitement happens here. So here's another example. R horizon is your unweathered parent material. This is like solid rock, pretty much. That C is a little bit broken down, but not much, and then you go up from there. So as you go up, the pieces of rock get smaller, and as you go down, you're going to have less and less organic material. So soil profiles by biome, which is on the bottom of 13. So if you look at something like temperate deciduous forest, you've got tons of forest litter. This is where most of the organic stuff is going to be. You've got tons of humus and minerals, much thicker layer there, and then you got this. A forest is going to have slightly different setup with the parent material being different, so you can look through these. Grassland has tons of stuff up here, a nice thick topsoil layer, and then much less down below. Tropical rainforest has very little of the organic layer because it's broken down so quickly. So rainforest soil is actually very nutrients poor. All of the nutrients are in the plants themselves. And then something like a desert is going to be thicker and drier with a lot of that stuff going on. So after that, here we go. So forests have a thick organic layer, bleached E. Grassland is very thick topsoil. Rainforest is thin O layer. And desert is no organic layer, very thin topsoil, and a very large B layer. So a little bit different for everybody. You now have two articles. Here's an example of forest that was burnt, slash and burn. So they can use it for farmland, which is stupid because it's the rainforest. So why would you let's go to rainforest, if you have a very thin organic layer and a very, very thin topsoil, why would you think to plant plants on it? No, that's stupid. Stop doing that. So anyway, burning down the rainforest for farmland is ridiculous and stupid. Soil services, so they do things like help with plant growth, cycling of nutrients, habitat, places for little critters to live, engineering medium, we use it to build stuff with, and it also helps with water storage and filtration. I made this before the bell rang, cool. So here are your different soil services. So these are ecosystem services provided by the soil. We need all of these things. After this, there are two articles. If you go to the file of this packet, you will have the links for that, but there's one on desertification explained. I would go through that and read the article and answer the questions, along with loss of fertile land fuels looming crisis across Africa. So those two things will help summarize this section of notes. And with that, you have survived these round of notes. Before I go, I want to let each and every one of you know that you are good enough, you are smart enough, and people do like you. And in case I don't see you, good afternoon, good evening, and good God, do your homework.